Welcome to electronics. Now we will discuss semiconductor devices. So, semiconductor has conductivity less than a conductor, but greater than an insulator, and current conducted through movement of charge carriers. So, you have free electrons, which have a negative charge, and you have holes, which have a positive charge. Electrons and holes flow in opposite directions. Electrical conductivity of a semiconductor is poor in its natural state, easily modified by adding impurities known as doping. It's easily controlled by applying an electric field. Semiconductor device is a device constructed so that its conductivity can be controlled by an electric field, essentially a controllable resistor. Two basic and common semiconductor devices are diodes and transistors. A diode passes current only in one direction. It goes current. Your current and your electrons travel from your anode to cathode. So that's why, if you remember from maybe from school, maybe in chemistry class, teacher used to say red cat gets fat. Reduction, cathode. You're getting negative charge. You're gaining electrons. So current is traveling from your anode to your cathode. So conductivity between terminals controlled by voltage between terminals. Um, the conductivity of a diode is either very high, so diode is forward biased, or it's going to be very low when your diode is reverse biased. The direction of current flow when the diode is forward biased is the direction of the symbol, the direction that the symbol is pointing in. So if you look, the symbol of a diode has this little arrow there. So it's pointing in that direction. That's the direction that the current is flowing in when it's forward biased. And also, on the exam, or in general, you're going to experience voltage drop across diodes. Now, most of the time, the problem will tell you what that voltage is, what the voltage of diode is. If it does not say anything at all, for the FE exam, you're going to assume zero point 0.6 volts. Okay. I know in a lot of colleges they teach zero point 0.6, some colleges teach 0.7, but the NCES they prefer using zero point 0.6 if they don't state it already in the problem. Transistor. So voltage or current applied to one pair of terminals controls conductivity between another pair of terminals. Can be used to switch current on or off, and a small signal. So small signal or small current. Here, small current can control much larger signal, so can be used as an amplifier. Can be modeled as a two-port or three-terminal device with three variables: current voltage, and impedance for each port. Performance model. The performance of all semiconductor devices is inherently nonlinear over the full range of response. In small signal analysis, performance is evaluated over small variations in input or signal voltage. Within each of these smaller performance regions, a straight line can approximate the device's behavior. For this reason, a linear model is used within each performance region, and the overall model is called a piecewise linear model. So, which of the following is not true for intrinsic semiconductors? A, there are holes in intrinsic semiconductors. B, there are free electrons in intrinsic semiconductors. C, they make good insulators. D, increasing thermal energy increases their conductivity. Of course, the answer is C. They're not good insulators because, of course, they're carrying current. So intrinsic semiconductors will carry current, so option C is not true.